Welcome back, class. In this video, we're going to practice using all of the exponent rules that we talked about in the previous video to simplify various combinations of powers of x. And our goal is always, in these examples, going to be to write whatever complicated, messy thing I have in terms of a single power of x. So, how am I going to do that? Well, here I have an x squared divided by an x cubed. And a way I can combine these is to think an x cubed in the denominator, that's the same thing as an x to the minus 3. This and this say exactly the same thing. So you should be comfortable swapping back and forth between the thing on the left and the thing on the right. But the nice thing about this product is that this is a product of numbers with like bases. And so the first rule we went over in the last video was that in this instance we add the powers. So this is an x to the minus 1. And so I said in the directions single power of x, so I'm going to write it as x to the minus 1. But remember, that would be the same thing as 1 over x. Okay, in this next example, we're getting a little more complicated. We have an x squared and an x cubed multiplied together, then raised to the 4th power. So the first thing I'm going to do is deal with the x squared and the x cubed multiplied together. There's a like base. Both of them have a base of x raised to these powers. And so in that instance, I add the powers. So I get an x to the 5th, all raised to the 4th. But now this is the case that I called stacked exponents in the last video. This is the case where we actually do multiply the powers. So 5 times 4, this now becomes x to the 20th. And so that is this written as a single power of x. Okay, here we have a square root of x to the 6th times x to the 10th. I have these like bases again. And so again, like bases means I add the powers. So this is going to be a square root of x to the 16th. And there is an immediate reaction upon seeing a square root and seeing a 16 and thinking, I know the square root of 16 is 4. This is just going to be x to the 4th. But the moral here is that the operations that you see don't just pass automatically into the exponent. So here I was multiplying two things, but even though I was multiplying two things, I ended up having to add the exponents. When I go to take the square root of a power of x, I definitely don't do that by taking the square root of the thing in the power. Instead, I need to remember how to write square root as a power. Namely, square root is the same as raising to the 1/2 power. So I can rewrite this as x to the 16th to the 1/2 power. Okay. Square roots and 1/2 power are the same. You're going to see that over and over and over again. But why was that useful? Well, I now again have this instance where I have stacked the exponents. And so I can now, in fact, multiply the 16 by the 1/2 and find that what I get is actually x to the 8th. And that is actually my answer to simplifying this. As a last example of this style of question, I'll go ahead and grab x squared times x to the 7th divided by x squared times x cubed divided by x to the 4th. And so in this example, we need to use both our fraction rules that we talked about in the last section and our exponent rules that we talked about in this section. Namely, let's first use our fraction rules, and let's use our fraction rules to recall that dividing by a fraction is the same as multiplying by its reciprocal. So I'm going to write this as x squared times x to the 7th divided by 1 times x to the 4th divided by x squared times x cubed. Dividing by this fraction was the same as multiplying by this fraction upside down. Okay, now I go to look at the numerator. I have x squared times x to the 7th times x to the 4th. All of these have the base of x, and so I add the powers. So 2 plus 7 is 9, plus 4 is 13. Okay. And all of this is divided by, and then x squared times x cubed, again, like bases, so I add the powers. I get an x to the 5th. Like earlier, my moral here is that since I'm dividing by an x to the 5th, that's the same thing as multiplying by an x to the minus 5th. So I'll rewrite it like that. And now that I've seen this, now I am multiplying things with like bases, so I add the powers. And so I get 13 plus minus 5. That is, in fact, 8. And so this huge messy thing that I started with, it's x to the 8th. As a last note for this example, often students will say, okay, well, what happens if I have something like x to the 5th plus x squared? How do I combine these? And the answer to this is very simple. You don't combine these. If I add two different powers of x, there's nothing I can do to combine them into one power of x. Okay, so these cannot be combined. Okay, so be careful that you don't invent your own algebra rules that allow you to combine things that you can't combine. As a last example for working with exponents, I want to talk about what happens when you are both adding and multiplying at the same time. Okay, so, namely, what happens when you expand things like this? So, namely, I'm talking about things like x cubed plus 2 times x to the 4th minus 6. And I want to make sure that when we multiply this out, we get the right thing. So, we're going to have to FOIL this, but as we FOIL it, we're going to have to make sure that we use the right rules to combine the exponents. So, if I think about FOIL as first, outer, inner, last, then first, that'll be x cubed times x to the 4th. And before I simplify that, I'm just going to write it out as x cubed times x to the 4th. Okay. Plus x cubed times minus 6, so that's minus 6x cubed, and plus 2 times x to the 4th, and then minus 12. Okay. And so the thing I want to make sure of in this exercise is that when I combine an x cubed and an x to the 4th, I always do it correctly, which is to say these are two things with a like base that are being multiplied, so I add the exponents. So that is, I get x to the 7th minus, well, I guess I'll put this one first, plus 2x to the 4th minus 6x cubed minus 12. I just put this first because it's a higher power of x. But the moral of this example and these practice problems in the homework is to make sure that when you multiply x cubed and x to the 4th, as tempting as it may be, you should never get x to the 12th. You should always make sure you get x to the 7th. Okay, what if I take something like x squared minus 3x to the minus 2 and I square it? Okay. I want to remind you, squaring is the same as multiplying it by itself, so this is going to look a lot like the previous example. Okay, so again, I'm FOILing, so I multiply x squared by x squared. And I multiply x squared by minus 3x to the minus 2. And then I multiply minus 3x to the minus 2 by x squared. And then I multiply minus 3x to the minus 2 by minus 3x to the minus 2. And I wrote these all out without combining them, just so that I can think only about what happens when I combine each of these pairs of powers of x. Okay, so when I combine x squared and x squared, I'm going to get x to the fourth. Now, as it happens, this is the one instance where if I add them or multiply them, I get 4. But here I'm supposed to be adding them, right? This 4 is 2 plus 2, not 2 times 2. Okay, plus, or actually minus 3 times. And so now I've got an x squared times x to the minus 2. Again, I want to add the powers, so 2 minus 2, that is 0. Minus, and then the same thing happens here. I have an x to the minus 2 and an x squared. I add the minus 2 and the plus 2. Okay. Then I have a minus times a minus, that'll be a plus, and then a 3 times a 3, so that'll be a 9. And then an x to the minus 2 times an x to the minus 2. Those will add, and so I will get an x to the minus 4. And this can be simplified in a couple ways. And one of the ways it can be simplified is by noting what happens whenever you raise anything to the 0th power. Namely, whenever you raise anything to the 0th power, you get 1. So this x to the 0 and this x to the 0, they're really just 1. So this is really x to the 4th minus 3 plus 9x to the minus 4th, which is x to the 4th minus 6 plus 9x to the minus 4th. That is our answer. I next wanted to do a couple of examples where the variable that we're dealing with is not in the base, as in x squared, x cubed, but rather the variable is in the exponent, as in 2 to the x, 4 to the x, like this. The rules don't change, but I want to make extra sure we're careful about how we apply them in this instance, because we'll see this a number of times throughout the course, but we'll see way more x squareds than 2 to the x's, so we want to make sure that when we see this, everything works out. So this is going to be 2 to the x plus 4 to the x times 2 to the x plus 4 to the x. Okay, let's go 2 to the x times 2 to the x. Plus 2 to the x times 4 to the x. Plus 4 to the x times 2 to the x. Plus 4 to the x times 4 to the x. Okay, what is 2 to the x times 2 to the x? Okay. The bases here are alike. The bases are both 2's. And so since the bases are both 2's, I add the exponents. In this case, the exponents are each x's. So I get x plus x, which is 2x. So namely, what is 2 to the x times 2 to the x? It's 2 to the 2x. Plus. Now, what happens when I have 2 to the x times 4 to the x? I can't add the exponents, but in this case, the exponents are actually alike. And so I can remember that one of my rules of exponents is that if you have a product raised to a power, it's the same as the product of each of those things individually raised to the power. And so if I read this backwards, I actually see that 2 to the x times 4 to the x, it's the same thing as 8 to the x. Likewise, 4 to the x times 2 to the x, that's also 8 to the x. And if you're really clever here, you'll actually notice that there's 2 different ways I could write 4 to the x times 4 to the x. I could write it either as 4 to the 2x, that is, by doing the same thing we did here, of saying, okay, these are like bases, so I add the powers. Or, these are like powers, so I can multiply the bases, and so you could have written this either as 4 to the 2x or as 16 to the x. Either of these would be acceptable. I'm going to leave it as 4 to the 2x for now. So then, what are we going to be left with? We'll be left with 2 to the 2x plus, okay, and I have an 8 to the x plus an 8 to the x. That'll be 2 times 8 to the x plus 4 to the 2x. And in a sense, this is as simple as I can make this. Now, emphatic note, 2 times 8 to the x cannot be simplified. There is no way that I can combine the 2 and the 8. So this is definitely not 16 to the x, if you're tempted to think about this. This is just 2 8 to the x's. Here's the one thing I can do, if I want this to all look just a teeny bit nicer. I can notice everything here is a power of 2. So I can rewrite this as 2 to the 2x plus 2 times, and the 8, that's 2 cubed to the x, plus, and then this 4 is 2 squared to the 2x. And I can follow my nose through the various rules here to rewrite this. So this is 2 to the 2x plus 2 to the 3 to the x. This is the stacked exponents example. So this is 2 times 2 to the 3x plus, and this is also the stacked exponents example. So this is 2 to the 4x. Now, there's actually one more piece I can sort of put together here, which is that this 2, it's really a 2 to the first power, which is the same trick as rewriting every number as a fraction by writing it as itself divided by 1. Every number I can also write as a power by writing it as itself to the first power. But in particular, there's a like base here, and so I can combine these two powers. And so probably actually the nicest way to rewrite this original thing is to rewrite it as 2 to the 2x plus 2 to the 3x plus 1 plus 2 to the 4x. All right, I will do just one more example of this. And so as my last example of this, I will go ahead and multiply out e to the x plus 2 times e to the minus x minus 2. When I do this, I'm going to first get e to the x times e to the minus x. And I should mention here, by the way, e is just a number, and we'll be talking a lot about e later, but anytime you see e, it's this specific number that's something like 2.71. All right, but we're just going to leave it as e. We're not going to replace it with a decimal or anything like that. So we've got e to the x times e to the minus x, then minus 2 times e to the x, plus 2 times e to the minus x, and then minus 4. And what's e to the x times e to the minus x? I have like bases, so I add the exponents. So that's going to give me an e to the 0 minus 2e to the x plus 2e to the minus x. And there's no way I can combine these two things because they're added and they're not the same. But then I have a minus 4 here. Okay. But e to the 0th power is 1, like everything to the 0th power. So I'll get 1 minus 2 e to the x plus 2 e to the minus x minus 4. And so the 1 and the 4 I can combine to be a minus 3. This will be a minus 2 e to the x plus 2 e to the minus x minus 3. And that's about as simple as I can make this. Okay. This is the end of the material for Test 1. So, Test 1, reminder, is going to be Friday, October 9th, and it is going to cover sections 1.1, 1.2, and 1.3, which were our section on factoring and dealing with cubics and that kind of thing, fractions and solving equations with fractions, and the rules of exponents and simplifying things with a bunch of rules of exponents. Okay. So that's it for this. The next playlist will start the material for Test 2. But until then, be well.